Hi, Liam. Hello to everyone watching this video. I'd like to dive deeper into how a neural network is structured and how it works. You've talked about how the neural network is organized, but I'm curious to know how each individual neuron works. Could you explain it in simple and accessible terms? After all, I'm a beginner when it comes to learning AI.
Hi, Jessica. It's great to chat with you again and to everyone on the other side of the screen. Let's continue our conversation. First, let's start with the fact that a neuron is a mathematical model or function that performs specific calculations. It works in tandem with other neurons, forming a layer of the neural network. Each neuron receives input data, processes it, and passes the result onward.
Yes, you've already mentioned that, but I'd really like to know what the input represents. How does this work?
Inputs can vary. It all depends on what kind of information is being fed into the neural network. For example, if the neural network is analyzing an image, the inputs could be the pixel values of the image. Other data types could also be used, like numbers from a data set. Remember, we're talking about mathematical models, so all the information entering the neural network is in numerical form.
So each neuron receives its own portion of data for analysis?
Exactly. And each input is assigned a weight. This is a number that determines how important this input is for the neuron. The higher the weight, the more the input affects the neuron's result. I mentioned this in our previous meeting, but there are some interesting nuances that are worth discussing, and that's what we'll talk about now.
How do you determine which inputs are more important for a neuron?
Well, that's one of the most important aspects of how a neuron works. Imagine that one of the inputs is a pixel of an image, and the weight of this input is the value that determines how important this pixel is for solving the overall task. After all, the task the neural network is given can vary. For example, image editing or generating based on certain parameters. So if the neural network is recognizing a person's face, the pixel in the eye area will have a higher weight than the background pixel.
Ah, I get it. So the neuron evaluates the importance of each input. What happens after it receives all this data?
After the neuron receives all the inputs with their weights, it sums them up. That means it multiplies each input by its corresponding weight and adds up all the results.
Interesting. And then what happens?
After summing them up, a value called the bias is added to the result. This value is calculated using a specific mathematical formula. It's an additional parameter that helps the neuron shift the output in the desired direction, making the neural network model more flexible and adaptable.
So the bias helps the neuron fine-tune its response to the data?
Exactly. After that, the result goes through an activation function. This is a mathematical function that determines what signal the neuron will pass on. It helps the neuron decide whether it will be active or not, and it adds non-linearity to the model, allowing the neural network to solve more complex tasks.
The activation function is also calculated using some formula? Does it influence the result the neuron outputs?
Yes, it's very important. There are several popular types of activation functions today. For example, the sigmoid compresses the result into a range from 0 to 1. There's also the rectified linear unit, ReLU, which only passes positive values and turns negative values into 0. Another one is the hyperbolic tangent, which compresses values into a range from -1 to 1.
So, the activation function helps determine what output the neuron will pass on?
Exactly. The activation function helps the neuron decide how strongly it should influence the network's output. After that, the neuron passes its result on to the next layer or to the final output of the network.
So, the neuron does quite a lot of calculations to determine how important its contribution is to the neural network's work?
That's right. Each neuron participates in processing information and makes its contribution to the final result. That's the core of how neural networks work.
It sounds quite complicated, but now I understand how everything works. Thanks for the explanation.
You're welcome. I'm happy to help clarify things.